Okay. Whoa, sorry. Okay, here we go. Hi, I'm back. I had to charge my phone for a few minutes to have enough power to do this because I'm terrible about charging my phone. Okay, so let's see here. We're going to see how fast we can get through this page. This is page 3, number 2. Evaluate the following log expressions. So these are ones where these should be doable without a calculator. You're asking yourself 6 to what variable equals 216. So you can use the definition to think of it like this. Okay, and then 6 to the x is 216 is the same base, which is, I think, to the third. I'm losing my mind right now, but I think it's a 3. Is it a 3? Let's check. 36 times 6. Yeah. Okay, box it up. All right, this one right here, I'm going to go ahead and set it equal to x, and the question is base exponent equals 7 to the what equals 1 over 49. Now keep in mind 49 is base 7 as well. Okay, animal, I hear you. Hold on. This is 7 to the negative 2. So x equals negative 2. Now, I just got rushed and distracted by my dog. Let me make sure I did that right. That is 7 squared, 7 to the negative 2. Yes, BRB. Gotta let the dog out. Okay, I am back. He'll be banging on the door in just a minute to come back in. Okay, so let's see. This is 9 to the what equals 1. 9 to the what equals 1. X must equal 0 for that to be true. And then this is just hard to explain, darn it. It is, this is what I see. I always point and go base E. And what I mean by that is it's log base E of E. So the question is e to the what equals e, and that's a 1. So remember these guys undo each other and they basically give you a 1. Confusing. Oops, got a box to be consistent. Okay, next one, number 3. Expand the following logarithmic expressions. So expanding and condensing. Boy, I just graded your guys' little check-ins today, and the expanding and condensing was horrible. So expanding is where we're going to make this bigger. Now, where should I write the rules here? I'm going to write them across the top. You might want to write them down too, and then I'm going to reference them so you know which ones I'm talking about. Rule number 1 basically says if you've got log of any base, I'm going to leave it base 10 just to make it easier to write. Log of any base of u times v. You can expand it into 2. Okay, that's rule number 1. You can expand it into the sum of 2. Rule number 2 says if you've got a log, let's say base 10 of u divided by v, then you can rewrite that as 2 logs being subtracted. Okay, and then the third one says, let's see, log base 10 of u to the v, that exponent can be brought down out front and multiplied times what's left. So that's rule 1, 2, and 3. Take a second and get those written at the top of your paper. And then as I do these problems, I will refer to those. Okay, so this right here, there's a couple of different ways. So this one is going to use rules 1, 2, and 3. You've got a multiplication, you've got division, and you've got exponents. The multiplication is this one, the division is this one, and then the exponent's this one. So we're literally going to use all 3. So I'm going to go piece by piece. So I'm debating right now how to explain it to make it the easiest for you to follow. Some of you might like to move this to the top and make it a negative 8. If you followed what I just said, I actually think that's pretty straightforward. Here's what I think most of you will do, though. I think you'll go like this. I think that's what you'll do. I just used rule number 2. I took a division and I separated it into 2 logs with subtraction. I took a single log that had division and I separated it into 2 logs with subtraction. Notice I've still got this multiplication right here. So that one, now I'm going to go use rule number 1 and rewrite this as log base 3 of x to the 5th plus log base 3 of y to the 3rd minus what was already there, z to the 8th, okay? So now I've got all this, and I'm almost done. I just need to bring down each of these exponents. So that 5's coming down to the front. That 3 is coming down to the front. And then that 8 is coming down to the front. Bam, nailed it. Okay. Now this one's trickier because there's two things down in the denominator. Now there's two ways you can think about doing this. You can move this up and make it x to the negative 4th, and move this up and make it e to the negative 3rd, which I kind of think might be the easiest. However, the one I was just looking at that you guys did on your check-in today, you tried to do it by subtracting. So I think I'm going to do it that way because a lot of you missed the negative, and I want to show you what I mean. But if you want to take this and make this x to the negative 4th and make this e to the negative 3rd and then have everything be rule 1, you can totally do that if you follow what I just said. All right, so I'm going to have natural log z to the 3rd minus natural log x to the 4th e to the 3rd. So I'm going to have this, but now I'm subtracting this whole thing. I'm going to split this up using rule 1, but when I do that, I've got to put parentheses, which is what a lot of you missed on the check-in. You've got to have this negative sign distribute to both of those is kind of the idea, because they're both in the denominator, so they both need a negative, if that makes sense. So I'm going to do another step here and show you that distributive property with that negative. Okay. So now I'm going to bring the exponents down. That's rule number 3. And I noticed this right here, if you go back up here, the natural log of e is equal to 1. Well, guess what we're looking at right here? A cute little 1, and this is multiplication, so this is 3 natural log of z minus 4 natural log of x, and then 3 times 1, which is negative 3. Okay. Oof. Yikes-olas. So this is, I'm afraid I'm going to run out of space, so I'm going to simplify right here to the side for just a minute. This right here is 4 times 3. 4 is a perfect square, and then this is x squared times x squared. So this is a 2 x squared root 3. Hopefully you followed that, over y squared. That sucker simplified is this. Okay. So now what? Let's see, there's a couple of different things to do here. I think I'm just going to go for it and write it like this. Okay. I'm going to split up all of these at the same time on this next step. I'm going from 1 log to 2 logs, and now I'm going to go from this 1 log to 3 logs plus that log, so 4 total, if you followed that. Now, I'm going to do something uber tricky, and you're going to get lost, so pay attention. This square root of 3, I'm actually going to write it as 3 to the 1/2 exponent. So a square root can be rewritten as a 1/2, so pay attention to that, minus log y squared. I'm going to do a quick double check. I've got 4 logs, all base 3, except for sloppiness right there. 2x squared, 3 to the 1/2. Okay, this right here I can't do anything with. Good job, you. Okay, this right here I'm going to bring the 2 down. This right here I'm going to bring the 1/2 down. Ooh, I see something right there. Minus, I'm going to bring that 2 down, log base 3 of y. This can be rewritten as a 1. So I'm actually going to have log base 3 of 2 plus 2 times log base 3 of x plus 1/2 minus 2 log base 3 of y. Why is this 1/2? Because that's a 1. 1 times 1/2 is 1. Yikes, olas, that is hard, tricky business. So on all of these, we went from a single log to multiple logs. We expanded it out. The directions for the next part are to condense. That means get a single log And this did not go well on that check-in. I don't think you guys understand that we're trying to get it down to a single log. So right now I have 3 logs and I want to bring it into 1. So I've got to use these guys going in the other direction. I've got to take multiple logs and turn it into 1. I've got to take multiple logs and turn it into 1. This is how I'm going to do that. Okay, so, wow, I thought this page was going to go quick. I'm not sure why I thought that. That was a lie, clearly. Okay, log base 10 on all of these. That's good, because when they're all the same base, then I can bring them together. I'm going to deal with exponents first. Let's make that a positive and take up a negative 2. We were doing that, and I think everybody was appreciating that. So now it's plus and a plus, so this is all going to be multiplication, which means it's going to be x to the 5th times y to the 3rd. You don't have to write that multiplication. I'm just doing that so you cuties can see. And then this needs to be moved down. So my final answer is a single log, x to the 5th, y to the 3rd, divided by z squared. I've got a single log. I went from 3 logs down to 1. And when you look back, do you see that that's negative right there? And then these two are positive, so they're multiplied. Okay, coolio. Ooh, distribute the negative sign first. I'm going to distribute the negative sign. Yeah, I'm going to do one step at a time so I don't lose you. Again, these are all log base 10 common logs here. I'm going to use those exponents and move them up. Log x squared plus, I'm going to move up a negative 2 plus log z to the 4th. Okay, so now it's addition, so I'm going to use rule number 1 up here. I've got addition of stuff, and so I'm going to make it multiplication. Okay, oh my gosh, it's 10:03, people. It's 10:03. And I haven't even started grading your ESQs. Okay, so what am I doing? I can't make my brain work, sorry. So I just took 3 logs and condensed it down to 1, and this is the one that needs to go down because it's a negative exponent, so log of x squared z to the 4th divided by y to the 2nd. There she is. Okay, tricky business, here it is. Distributive property is going to give me 2 natural log y cubed plus 1/3 times 9 is 9/3, which is 3 natural log of z squared minus 5 natural log of x to the 4th. Okay? That exponent needs to go up. Now, this is hard because it is raising a power to a power. Same thing with this 3. It needs to go up, but it is raising a power to a power. And then same thing here. Let's take a negative 5 up, which might freak some of you out. I hope not. Okay, that's not minus 5. I mean, it is a minus 5, but this is still multiplication right there. Okay, so this is going to be the natural log of y to the 6th plus the natural log of z to the 6th plus the natural log of x to, let's make that a bit, to the negative 20th. Okay, so this is 1 natural log with all of these multiplied. And then that needs to go down. What am I doing? Y to the 6th, z to the 6th over x to the 20th. Nailed it. Bam. Hopefully that helped. Started with the distributive property. I think I was pretty consistent here with taking any negatives here and moving it up to make it an exponent and then bringing that down into the denominator, but you could also just see this as subtracting. Okay, my goodness, hopefully we can go faster right here because this is taking as long as graphing. Log base 2 of 33, evaluate the following using the change of base formula. Uh-oh, am I going to have to get a calculator? My phone is my calculator. Okay. Well, this will be fun. Okay, so we're going to go upsy daisy, downsy daisy. So it's going to look like this. Log of 33 on top divided by log of 2. So what we just did is we just did the change of base. If you wanted to, you could change it to any base. but our calculator is log base 10 or the common log or the natural log, log base e. And so usually we change it to one of those two. And now you're going to use your calculator and figure out the answer, and it's going to be a mystery until tomorrow. You can check the board to figure out what that is. You do want to round to 3 decimal places, so be sure you can do that. And then this one right here, very exciting, is going to be log 17 divided by log 2. And these are all base 10. And so again, I'll use my calculator tomorrow when I get to school, and you can check that answer on the board with the review. I wrote both of these here because I want to remind you it doesn't matter. I like to use common log because I like it. Mr. Pi uses this one, so he would do the problem this way and I would do it this way, and we'll both get the same answers and we're both right, and one's not better than the other. It's just kind of a preference thing. Okay, and so sorry I don't have full answers on those. These guys right here are all screaming at me. Well, not this one, but these two are screaming at me. I've got the same base. I've got the same base. So same base. So x must equal 15 minus 2x. If I want this side to equal this side and the bases are the same, then I just need the numerators, or not the numerators, sorry. I just need the exponents to equal each other and I'll be golden. So I'm going to add that 2x over and I get 3x equals 15. So x must equal 5. If I do that, yep, that works. Nailed it. Okay. And then now, that's base 3. So this is 3 to the second to the x. So these guys get multiplied just like we were doing over there. So this is 3 to the 2x equals 3 to the 7 minus 5x. So because my bases are the same, then that means that 2x must equal 7 minus 5x. Add that over, I get 7x equals 7. X must equal 1. Have I just gone off the page? X must equal 1. Take that one. Like, ooh, wait, what is that? Did I just do good math? Oh, yeah, sorry. If I put a 1 in here, 9 to the first is the same as 3 to the second. Yep, good. That freaked me out for a second, not gonna lie. All right, and then finally, I want to point out, oh, I've got a pencil right here. This is the exponential right there. So you see how it's got this minus 9 and this multiplied by 3 thing going on? We need to undo that. So I'm going to add 9 over. So when I add 9 to both sides, that gives me a 15 over there. Now, here's my exponential still, this part. So I need to divide by 3 to get rid of this 3 out front. So I'm going to have 2 to the x minus 2. Divide that over, it gives me a 5. So here's my actual problem. So now this is the part where I do it 2 different ways, which we haven't talked about since last week, so your brain may not be quite ready for this, so you got to get it back on. Okay, there's the definition way, which I prefer, which is, here's my exponent, and it equals log base 2 of 5. So x equals log base 2 of 5 plus 2. I'm going to add that 2 over. This is the exact value answer. If you want to figure it out as a decimal, you can. I'll tell you what I want you to do on the test. If you don't like using the definition, that's what we used here, definition to solve. If you want to do it using the inverse, I should probably put, okay. If you want to do it using the inverse, then you would go log base 2, log base 2. These undo each other and you get x minus 2 equals log base 2 of 5. So x is equal to log base 2 of 5 plus 2. Same answer either way. Same number of steps, nothing super exciting. It's just kind of what you see. Okay, thanks for listening. God, that took 19 minutes too. Goodbye.